this is the idea. This was explained by Richard, but essentially, I've walked all over this area, so you don't have to. But I would absolutely recommend it. But we are living in some of the most extraordinary countryside, and you shouldn't underestimate its beauty or its meaning in terms, or geologically, its meaning in terms of how it got there. So I'll start with this. This is obviously Box Hill. This is the view from Box Hill. Starting with the scarp over here. This is Dorking. You are about here. No, actually, that's the church. You're there. This is the Green Sand Ridge, Leith Hill, that Richard was talking about. The mole goes down along here. The Gault clay is down here. And this is the Weald, this broad open plain here. Somewhere out there, there are some more hills, which are the Jurassic, but essentially they're a long way away. And there's a lot of Wealden clay and other material being eroded away from here. So a fantastic view from Box Hill across the lower Cretaceous. Now, just to put things in place, this is the OpenStreetMap. So Dorking down here, Leatherhead, and other important places. That's where I live. Box Hill is there, and you were looking south from there, off in this direction, well, or right the way around that arc there. But that's just a map. It's just flat. Let's put some topography on it. So I'm going to be using quite a lot of this LIDAR data. Now, this is topographic data that's freely available online. It comes from the Environment Agency and is down to 50 centimeters resolution, both vertically and horizontally. And it covers the whole of the country. It was flown from airplanes a while ago, and it's just there to be used. And LIDAR stands for light detection and ranging, and whatever that means. So some lovely, you know, you get the fancy software and then you can drape something on it and it makes it all look nice. Just in case you were wondering, that's where you are at the moment. This quite clearly is the Mole River going through here, Leatherhead up here, etc. This is, LIDAR comes in two flavors. There's this one, which is the surface model, which is basically what's there. So you can see, you know, all the trees and the buildings and the whole of Dorking and railways and everything there. And it also comes in a terrain model where, using fancy things in their computers, they can remove all of that stuff. So it sees through the organic matter anyway, but they've removed all of the buildings and everything else. Obviously, some things you can't remove. The M25 is one, railways. But essentially, this is the surface. This is the surface of the Earth, and it is very old. We're going to start with looking at a little a picture from Box Hill here, across in this direction. And this is Ranmore Scarp. So Ranmore is up here. This is Denbies. Richard mentioned that. You'll be seeing more pictures of vines. But the important thing here is that here is a steep scarp running down, and then the gentle dip slope of the chalk as it goes off to the north. The this valley here, this is not the front of the ridge of the North Downs. That's there. This is a dry valley at the side, just behind there. And this is that valley, covered in all sorts of wonderful grapes. And that little spire there is Ranmore Church, if you're aware of it. If you look the other direction, then basically that's what you see. So again, the thing I just described, which is that steep slope, grading off to very little down the bottom here, and then that gradual slow dip of the chalk to the north. This is the LIDAR data just colored up. That's all I've done in terms of heights. And the range of heights is quite well, it's quite a range of heights, let's put it that way. So the highest point around here is along to the west. No, yes, to the west. And then not Box Hill. Box Hill is not one of the highest points, but a bit further along. Weirdly, neither of these points have names. You'd have thought somebody would have called them something, but I can't find a name for them. At the foot of the escarpment down here, the Mole Valley is at 40 meters. So the difference is something like 180 meters between the top of the hills and where the Mole Valley goes through before it goes through the valley. Richard mentioned the Pit Brook, which runs along here. It drains this front of the chalk scarp within the Galt clay down here, and the Mole turns left as you come out this way, and then runs along the Galt in this direction before it cuts through these sands. But the Mole drops about 10 meters through the Mole Valley. Up here, it's at 30 meters and 40 meters here. So there's about a 10-meter difference as you go through. Now we're going to look across at Dorking from the top of the hill there. And just, I keep doing this, but there you go. That's the church in Dorking. That's the Greensand Ridge behind Dorking. And this is all chalk. Just the scarp is just the other side of these trees at this point. This is the geology. So again, Richard has described this, so I won't spend a lot of time on this, but here is the Wealden, Lower Cretaceous. This is the lower greensand, these green colors here, that one, and some others down there. That's the Galt clay running through there. That there is the upper greensand, and then you've got the chalk from here right the way through to here, and there's lower chalk, middle chalk, and upper chalk. Up here, you come to the tertiary with an unconformity sitting on top of the chalk. This is the Thanet sands, and then the Reading beds, and finally the London clay, which just goes on and on and on. So there you have it. Going to look off in that direction now from over there. And again, just to re-emphasize, the base down here is Galt, then you've got the upper greensand in here, which is mostly worn away, but the scarp is in the chalk right the way up. In terms of ages, Lower Cretaceous is about 113 to 134 million years. The Upper Cretaceous, the chalk, is in this instance, from that unconformity, is about 72 to 113 million years worth of deposition. And then the Eocene is all of this lot. The Paleocene is about roundabout 59 million years, and the year seen is less. It's worth dwelling on that. These are very long periods of time. Geological processes are very slow, but they are inexorable. The other thing it's worth thinking about, or worth remembering, is that the chalk is split. Just go back into that one, into the lower, the middle, and the upper chalk. The big difference is, as far as we're concerned, of those, is that the lower chalk has clay in it, and the upper chalk has most of the flints in it, and the middle chalk is a bit of chalk in between. Now, that means that the old lime works and the cement works. So this is Dorking. This funny thing here is Betchworth, and there are some others along here. They were all focused on the lower chalk, because you need clay to make cement. You need clay in your chalk. And like I say, most of the flint you'll find in the upper chalk. That's important, and we'll come back to it. So we looked at that. Right, so let's look at some of these extraordinary features, because obviously there's, the Mole Valley, but there's these things off the side which are just beautiful and very distinctive. So just to describe them, what you have is a meandering valley here. There's another one over there. There's another one here. There's another one further along, with a steep south-facing slope. That's this side of the valley, and a gradual slope on the other side with these deeply incised valleys all the way up there. Very distinctive. The two sides of the valley, very, very different. So what we're going to do is we're going to look over here, first of all, at the slope of the chalk itself. I'm going to look up the slope and then down the slope. Oop, come on, there we go. So this is on Effingham Golf Course, looking up the slope, and you've got this sort of gently undulating slope along here, and you're actually on the chalk here. And so these wonderful wildflower meadows, chalk meadows. And if you look the other way, you can see right the way across the London Basin. This is the London Basin out here. So essentially, most of what you can see there is London clay. And if you don't believe me, this is the same view from Norbury Park. And that little bit there, you can see London. You don't believe me, do you? No. So there you go. So there's the Shard. And here are a bunch of other of the London buildings. So you can see London from the North Downs. So that picture was taken from here, Norbury Park, Norbury Park, looking off in that direction. Now we're going to look along the Polesden Lacey Valley, which is this one here. So I'm going to show you some pictures down, view down here, and then a view up at its end, because it comes up here and then turns up and then sort of peters out. So this is the Polesden Lacey Valley. Again, this is the south-facing slope, so it's relatively steep, but sort of nicely undulating and smooth. This is the base of the valley running beautifully meandering down through here. And this is its where it begins to peter out as you go up the hill after it's turned the corner. So Polesden Lacey itself, so I've switched to the surface model here, so you can see the buildings. Polesden Lacey is there, and then West Humble is here. if you know West Humble. There's a valley coming up there. This is Polesden Lacey. That's the National Trust House in Polesden Lacey. And this is its valley. So it was sited beautifully to overlook the dry valley. And this is the view from the other side of the Mole Valley. This is West Humble, and this is the mouth of that Polesden Lacey dry valley. And you can see it meandering off, and eventually it goes off around that corner there. So it's a beautiful valley. And on the southern side of the valley, you get these steep-sided little valleys. You don't see anything like this on the south side. Steep-sided valley running down into it. Here's another one. This is Hogden Lane, and that is genuinely the side of the valley. So there's a series of these. This is the Polesden Lacey Valley. Hogden Lane I just showed you. I showed you one of these as well. But there's these Honeysuckle Bottom, if you know it. Green Dean runs right the way through, and various other ones around. Now, if you've ever driven along the A246 up here from Leatherhead to Guildford, which is about where that mark is on the brick, you may have wondered why the road goes up and down and up and down and up and down, because it does. And that is simply because what you're doing is you're driving over the next set of these valleys that are running off of this ridge halfway down the chalk. So these valleys here. And if you drive along here, next time you do that, if you do it, you need to remember that every time you do this, which will be very common, that's another glacial valley, periglacial valley. And so this is an example. This is a wonderful old picture from Effingham. This is the old toll gate at Effingham, a chalk surfaced road. If you took somebody from the 1800s, which is when this was taken at the end of the 1800s, and plunked them down into Effingham or anywhere around here today, the first thing that they would notice and think, oh, that's odd, is the colour of the roads, because they were all chalk surfaced in those days. So white roads, a gentleman of the road, and some vehicles. But this is another one of these dips. So that was actually taken there, looking at that dip there. Now, on the other side of the Mole Valley, over here, we have, this is Headley up here, this is the Headley Valley, which is pretty much doing exactly the same thing on the other side. The valleys over here aren't really called anything, with one exception. This is Headley Heath up here, and then down here is the Zigzag Valley and the Zigzag Road. If you've ever been up to Box Hill, you've gone up the Zigzag Road, it's that valley there. So this is the Headley Dry Valley. Again, much the same as Polesden Lacey on the other side. There's the south-facing northern side of the valley. So steep, smooth, and gently undulating. And here are some of the steep valleys running down towards the north on Headley Heath. And it's quite obvious that it's very different from the other side of the valley. But rather beautiful. And that's the next valley going up there. This you may recognize. There's a road there. This is the Zigzag Road. It's come up there, goes around there, and goes up here. So this is the Zigzag Valley. And as you can see, and if you've ever been up there, you will know this is a very steep-sided valley, as they all are. and is a very good example of one of these steep valleys, incised valleys running down towards the north. So that gives you an idea of a description of what's going on here. But how do they form? Now, if like me, you actually live on the chalk, your terrain is classified as thin soil over chalk, which is exactly what you're seeing here. This is the soil, this is the chalk. There's precious little for things to grow in, but they do, rather miraculously. But even after last night's thunder and lightning and torrential rain, everything else, water's gone. It goes. It sinks into this stuff like nobody's business. There is no erosion on the chalk. So that's a bit weird. No runoff, no erosion. So really, if you're going to erode out those valleys, they can't have been, it can't have happened during, you know, recent times, because the water that goes in there disappears. And in fact, if you're going to erode that stuff, it can only have been done when the ground was hard. And that, of course, was when it was frozen. So a little bit about the Ice Age. Over the last 50 million years, we have been getting gradually colder and colder and colder. So from about 50 million years ago, in the beginning of the Eocene, average global temperatures were considerably warmer than they are now. So this is the time of the London climate. So in that period of time, things have got a lot colder. And in the last couple of million years, and I'll close in on this, it's got a great deal colder again. And it could be because around here, the Isthmus of Panama, basically South America and North America joined. And so you couldn't get oceanic circulation going around there. So oceanic circulation patterns changed completely, and you start in this area, you start getting these much colder temperatures. Let's just zoom in on that and just note that humans have only been around for this little bit of time here. I'm going to say hominins that are only going to be around for this little time here. And we might worry about what we're doing to the climate, but we're doing nothing compared to this. Mind you, that's over 50 million years. So this is the last 5 million years, Pleistocene over the last 2.5 million years. And you can see what happens is that there's a steady downward trend, but it also starts to get very much more variable. And these points here, all of these little points, the minima along here are the ice ages. And then between them, it gets quite warm again, but only relatively warm, not as warm as it used to be. So it goes up and down and up and down. The maximum, okay, was at this point here. And then the most recent was here, and we'll look at those sorts of things. One of the things that happens during an ice age, when you create a lot of ice, hence the name, and then you pile it on land, is that sea level goes down, because basically you're locking up that water and sticking it on land in terms of thick ice. And so sea level has gone down, or at those times was very much lower than it is now. So this is the maximum. This is the one that Richard was talking about, where it is believed that the ice came down to just north of London. In fact, the Thames used to run out through Suffolk up here, and it was diverted during this time, and only now runs through to what we call the Thames estuary. This is the point at which, in theory, if there were hominins around, you could have stood on the hills here and maybe just have seen the glaciers in the distance. Maybe. But the other thing is that this is basically the edge of the land. The sea retreated way, way out here to what is currently the shelf edge. So there's sort of quite shallow seas, and then it drops off to the very deep sea, and that's here. And the Thames, there's bodies of water here, but the Thames, the Somme, the Seine, basically all of the North European rivers and all of the South British rivers basically emptied down into the Channel River, which went all the way down here and across to the shelf edge here. All of this was land. There was no distinction. That's the maximum. The most recent was the Devensian Ice Age. And this only ended about 10,000 years ago. Now, you might think that's a long time ago, but geologically speaking, that's yesterday. It is very soon. And during the Devensian, there was an ice cap basically on Scotland and much of Ireland and Wales and all of this sort of area. And again, same sort of thing before. The edge of land was way, way out here. And again, all those rivers, the now diverted Thames, joined up with the Rhine and the rest of it and poured down the Channel River. Now, our local area was down here, within what's called here an area of extensive permafrost. What does that mean? That means the ground is frozen. It is bloody cold. And the ground is frozen to some depth. Essentially, it's tundra. Whether or not you've got mammoths wandering around at the peak of this is another matter. But certainly, as it built up or as it went away, and if things got a bit warmer than they were there, and there would have been at the peak time very little vegetation for a mammoth or indeed anything else to eat. So what this does is, on the chalk, the freeze-thaw action, or just the freezing, chalk, as Richard explained, because of the Mole Valley, is very absorbent, takes a lot of water into it. And if you're in a very, very cold environment, then obviously that turns to ice. And ice occupies more space than water. It expands. That's why ice floats. It's less dense than the water. So it will break up whatever it's in. And that's what you can see here. Now, this is recent. This is freeze-thaw action recently. And you can see this is the top of the chalk, but it's just a mush of bits and pieces of chalk, and it's marl, really. Well, it's not even marl, it's just chalk mud. So what would happen during these periglacial times? So you get the water freezing the layers of the chalk, it breaks it up, and then if you've got a sunny south-facing slope, now, it may be the Ice Age, it may be very cold, doesn't mean you don't get clear days. So the south-facing slope, looking directly at the sunshine, warms up, and the ice melts, and all of this broken up material sloughs off, and gets washed away downhill during the next melt, rain, snow, whatever. So you develop on those south-facing slopes, the scarp. The reason the scarp is that shape is because you've developed these you've developed them by sloughing off material continually over long periods of time. On the other hand, if you're on the north-facing slope of one of those little dry valleys, then that never happens. It's just cold. But of course, it will still rain. You'll get melt. You'll get stuff coming off the top of the hills that will run down in these valleys, and basically you'll get erosion. So you get deep erosion on the north-facing slopes, and on the south-facing slopes, you get this even sloughing away of the surface. There are other things going on which we don't see very often. So these are two examples that I've seen from elsewhere. I haven't actually seen this around here, though I believe it does exist. This is a thing called cryoturbation, where essentially you've got water in the surface layers melting and then freezing and melting and dissolving some of the chalk underneath. This is chalk, this is chalk, and you get blobs of overlying material just sinking down into this melted surface layer when it melts. And at Broadstairs in Kent, where we went earlier this year on a field trip, there's this extraordinary set of blebs sort of sinking down into the top of the chalk cliff. Just remarkable. So back to our geology. That's our hard rock geology, but it's not the full story by any means, because a lot of that geology is covered in what is termed superficial geology. But actually, it's just, you know, the stuff on top of the last unconformity. And some of it is really interesting. What we have here is this stuff, all this brown stuff here and up here is called clay with flints. In the bottoms of the dry valleys, you get stuff called head. And then obviously, and Richard mentioned this, through the valley itself of the mole, you get these terrace gravels, the terraces. So let's start with clay with flints. What is clay with flints? Well, basically, it's what it says on the tin. It's clay with flints. And if you've ever walked up on Ranmore in the rain and wondered why it's so muddy and sticky and horrible and wet, it's because of clay with flints. And so a lot of people sort of think, ugh, it's horrible. But actually, look a bit closer, because it's fascinating. So this is it's the same thing, it's just an exposure, a bit closer. What it's made, lots and lots of flint, but different sorts of flint. There are big nodules of flint, and there are lots and lots of broken, sharp, broken flints in there. Now, hollow flints are quite common. You can see something there and here. And you can imagine, you know, water getting in there, freezing, expanding and breaking up the flints. So that freeze-thaw action creates broken flints. So you've got nodular flints, you've got broken flints, but also you've got flints like this, and indeed like that one there, which is completely rounded and has chitter marks on it. Now you might say, what on earth is a chitter mark? Well, chitter marks are what you get when you bash flints together over a long period of time in somewhere like a beach. So if you go to Dungeness, for example, where the whole Dungeness Peninsula is basically flints. And you look at them, they're all very well rounded, and they've all got these chitter marks on them. And if you can't be bothered to go to Dungeness, then just go to Ranmore Church and look at the flints that are on that, because they are the same. They may have come from Dungeness. But they're well-rounded, and they've got these little marks on the surface where the flints are bashed against each other over and over again. Think about it. Why are there beach sediments sitting on top of the chalk? Really interesting. In fact, why is there clay on top of the chalk? Where's that come from? I mean, it's not come out of the chalk, because the only bit of the chalk that has clay in it is the lower chalk, which is a great deal lower down. Now, you might, and obviously you do, get the nodular flints out of the upper chalk, and that's sitting just underneath it. But where have these other things come from? Where's the clay come from? Now, it's thought that, well, it's not thought. So this is classified as what's called a Remanier deposit, which is a remaining deposit. It's what's left after you've dissolved a lot of stuff out. And what you're seeing here is, if you like, the fossil history of what's gone. And what's gone is the tertiary. I mean, some of the chalk as well, that's where some of the flints come from, but not necessarily locally. Richard showed that over time, the whole of the weald got uplifted and then eroded back and eroded back and eroded back. But there was stuff sitting on the top of that that has then been washed downhill into the clay with flints. The clay up there has come from the Wealden, but when the Wealden was higher. It's the only way to do it. Possibly one of the most interesting deposits in the area, and it's a flipping nuisance when you're walking over it on the in the Wain. So that's the clay with flints. Now we'll look at the head. I'm going to guess now. Why is it called head? Well, because you find it in the heads of valleys. And that's what you see all over the place. And this is what it looks like. It's slightly reddish silt. It's got scattered flints in it. Some of them are in bands like this one. And there's another band you can see just along there. So unlike the clay with flints, actually, I should go back to that because that's important. No organization in this at all. It's just a jumble, okay? So it has undoubtedly undergone a considerable amount of cryotubation. So the ice and the freeze thaw and everything else has basically jumbled this up over and over again. The head, on the other hand, which, as I showed, you find in the valleys in between all this stuff, just underneath the clay with flints, does have bands in it, does have some stratigraphy, but has quite a lot of this reddish silt. It's basically, not surprisingly, eroded clay with flints, but there's other stuff in there, which is possibly wind-blown silt that's come across the northern European plains during the when it was tundra. And that's in places that gets concentrated into areas of brick earth. Called that because very good for making bricks. This is a genuine periglacial sediment. It was formed at that time. And here's an example. Go back to Polesden Lane, and you go down the lane. You have to be a bit careful about what's in the bottom because they've made this road up every now and again. But essentially, when you look in the sides, this is where you see the head at the bottom of these steep little valleys. Right, let's move on to the terrace gravels and the actual Mole Valley itself. Um, this is a picture where what I've done is use the same color spectrum, but this only goes up to 60 meters. So that's a 60-meter contour. And what it rather nicely defines is the areas through here, which are well higher than the current level of the river. So this is the river with its meander belt cutting through here, and around it, either side, at a much higher level, are a whole series of terraces. And it comes through here. And there's a couple of very important features as you go through the Mole Valley. One is called the Whites here on the edge of Box Hill, and the other is Druid's Grove over here. And they look very similar. They are basically river cliffs, eroded by rivers in spate. But the big difference is that this one currently has the river at its foot, and this one doesn't. We'll come and we'll examine that in some detail. So this is the southeast margin of the Mole Valley. That's Box Hill. And as you go along here, this is the Whites coming along. There they are. So this is a cliff, and the river goes in and erodes underneath that. And then you go off down the valley, down in that direction. There they are. That's Denby's. And this is the Whites here. It's 130 meters high. That's quite a cliff. If you go to our website, this is unashamed advertising. We have a website, Mole Valley Geological Society, mvgs.org.uk, but just Google Mole Valley Geological Society or MVGS, you'll get there. And in amongst the various things that you can do and see, our program, what we're doing, the geology of the area, those sorts of things, under information, you will see that there are a series of suggested walks, and I'm going to take you on a couple of those. This is also rather a nice 3D image of the LIDAR data. There's the Whites, and there's Druid's Grove there. So I'm going to start with walk 3, which goes down. If you're a biker, you'll know Rikers, and it's the cafe near the roundabout there in this point here on the way up to the Zigzag Valley. And so long as you're not there on a Saturday or a Sunday, we would all fit right in, because there's a lot of old bikers there. They'd happen to be wearing leathers, but you know, they're all of an age, and it's rather comforting, frankly. If you look at, we're going to go on this walk here, which is supposed to go and show you the swallow holes. This is, it's worth sort of taking a side issue. This is the current bed load of the mole. Okay, this is what it is currently moving around. It's basically silty sand. There's some gravel in there, fine gravel. It's basically eroded green sand and probably bits of pieces of weald, but mostly green sand, I should think. No chalk. Whenever I've looked, no chalk. And that's at least partly because it dissolves, it goes away. So even if you get slumps into there or it erodes into a chalk bank, the chalk will not last very long in the water. So let's go on this walk. Before we do that, I just want to show you, this is LIDAR again, and like I say, it picks out topography to 50 centimeters, And you can see these little things here. There's little depressions there, and there. Now, Richard was showing you much better examples of these. These are the swallow holes, or these are fossil swallow holes. There are supposed to be some in the riverbed itself down here. So let's go and have a look. So that's the whites from Burford Meadow, from the bit beneath, and this is all on terrace gravels. I'll just go back to that. So when I say terrace gravels, so this is the current, obviously the current level of the river, and then this is its current terrace. It's broad here. This is higher up. So this is an older terrace. And so we're going to walk along, firstly, its current terrace, and then later on I will show you some other terraces. So this is underneath the whites. There is not a lot of modern erosion going on there. The banks are stabilized by vegetarians. It's amazing what those guys can do by vegetation. And even during periods of high flow, there's not a lot of erosion going on into the whites, although there must be some just to keep them white. These are the swallow holes that I pointed out on the LIDAR, these things here in Burford Meadow. And when you go and look at them, this is what you see. So I'm sorry, I can't show a hole in the ground, but they're very good for blackberrying for exactly the same reasons that Richard said, that the soil obviously remains damp when everything around has dried out. So dry grass here and these bramble mounds, and typically next to or with trees growing in them. These are the stepping stones. It's a lovely walk. It's very easy. The river here is relatively low. Don't do it when the river is in spate, because they'll get covered. And somewhere around here, there's supposed to be evidence of the swallow holes. But this year, we had a lot of rain earlier in the year. You may remember that. And so the current water level is very high within the aquifers. And there was absolutely no indication of any water going down. Water doesn't need to go down when the water table is high enough. But it's a beautiful thing. You can look along the river and it is just beautiful. So let's go on the other walk. This is from Foxbury Shore, which is a lovely name for this patch of ground here, around to Swanworth Farm over here. And underneath Norbury Park, that's Norbury Park, the house, and Druids Grove, which is these trees here. And as I said before, this is another river cliff. Essentially, it's been eroded during periods of very high river flow. But as you can see, this is the 60-meter contour. The base of this cliff is 50, 60 meters up. It's nowhere near the current river. So we'll start off here and we'll walk across to Foxbury Shore. This is Foxbury Shore, a lovely river meadow. That's Norbury Park again in the distance. And in the middle of it is an abandoned meander. Well, I say abandoned, it was artificially cut off. And I was very keen to look on Richard's maps to see whether or not you could see when that was cut off. And certainly in the 1815s, the OS map, this meander, the river still went round this meander. But it does enable you to go and look at the base of a river. And remarkably, it's very shallow. Now this is obviously a meadow that floods, and it still does flood. This is, you know, even when did I go? After all the hot weather that we had, this was still damp through here. This is one end of the meander. It goes up round and then back over the other side, and that's where it joins the mole. So as a river profile, you know, it doesn't look like the mole should look. You'd have thought it would be bigger. That's the shape, and you can see why they cut it off. So the original river used up and went round there and then around there. And they cut it off because basically with these sharp turns, if the river was in flood, or it would just overtop these areas very, very quickly. So if you want to use this area for agriculture, then you stop that doing it and you allow it to flow through. So we walk a bit further along and we can see that this is the remains of the old river terrace. The river's over here somewhere, and the ground rises up gradually up to about 60 meters, about up here, well above the current level of the river. But it's terrace. This is still terrace. The back of that is the river cliff. So we know that there was a river up here at that level cutting that cliff at some stage in the past. There it is again, looking the other direction, with this gentle rise to, in this case, beachy wood. And these are the old terraces. And this is Ham Bank. So if you go to Ham Bank, you are now currently looking down 21 meters to the river, to the mole. The mole is currently eroding into this terrace at Ham Bank. And there it is doing that. This is the terrace, and the cliff up there goes up to about here and then goes up from there up to our 60-meter contour. The sediments here are basically sandy, fine-grained. There's nothing really holding it together, very easily eroded. Still beautiful. Now, I'm not going to take a long time describing this. If you want to know about this, then go to one of the book this comes from, which is by Clements. But essentially in the Thames Valley, you can identify a whole series of terraces of different ages at different levels coming down. And you'd have thought, oh, okay, well, maybe we can link up our 60-meter terrace or something to something. 60 meters is up here. You know, this is, like I say, the mole dropped 10 meters as it goes through the Mole Valley, and then it's out onto the Thames Plain where you've got a whole other set of things going on. So relating the terraces in the mole to any of these from mere height is very difficult because the mole is always going to be higher. So what you may be able to do is, you know, within these terraces, typically you get the temperate bits and then the cold weather gravels, and you may be able to identify some of our terraces. If you dug around and found things, you may be able to relate them. But the point is that out on the Thames Valley, there are a whole series of these that go on. And there's more than just these as well. And as soon as you get beyond Leatherhead, basically, you go off to what's it called? If you go to Cobham and Paynes Hill Park, and you go up to the vineyard at Paynes Hill Park and stand on that, on the top of that is a gravel. It's quite a coarse gravel, flinty gravel. That's the Lynch Hill gravel there. And that's on the top of Cobham. So you can stand on that and look back towards the Mole Valley and think, I'm standing on a terrace of the Thames over there. There are a whole series of terraces. Right, so going to wind up now and just go back to this amazing picture of what is an extraordinary periglacial environment. That's what you're seeing there. All of that essentially is a periglacial, the results of periglacial processes. There is very little that's happened. There is some, but very little that's happened over the last 10,000 years. So I'm just going to look down the valley itself. First, we're going to look down there. And that's the view looking south from Norbury Park. So that's the full width of the valley. That's the Whites and the back of Box Hill, and then all the way, and that's the edge of the chalk. Not that in the distance is lower Greensand again. And then if we look the other way, this is from the back of Box Hill. It's a lovely meadow going down back of there. Then this is looking out towards the end of the Mole Valley. Beautiful. Thank you.